The Venus debate. For decades, the scientific community had written off Venus. We looked at our planetary twin and saw a literal manifestation of hell. The surface temperature hovers around 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 92 times greater than Earth's, equivalent to standing a kilometer underwater. The clouds are formed of concentrated sulfuric acid. When the Soviet Union sent their heavily armored Venera probes to the surface in the 1970s and 80s, the machines barely survived an hour before they were crushed and melted into slag. Because of this, the search for extraterrestrial life in our solar system pivoted almost entirely toward the frozen deserts of Mars or the icy moons of Jupiter and Saturn. Venus was dead. A cautionary tale of a runaway greenhouse effect. But in September 2020, an announcement sent shockwaves through the astronomical community and abruptly yanked our attention back to the second rock from the Sun. An international team of astronomers, led by Professor Jane Greaves of Cardiff University, utilized the James Clerk Maxwell Telescope in Hawaii and the ALMA Observatory in Chile to scan the Venusian atmosphere. They weren't looking at the surface, they were looking at the temperate cloud deck, about 30 miles up, where the pressure and temperature are bizarrely similar to Earth's surface. And there, hiding in the millimeter wavelength radio spectra, they found the unmistakable chemical signature of a gas called phosphine. On Earth, phosphine, a molecule consisting of one phosphorus atom and 3 hydrogen atoms, is incredibly rare and highly toxic. It is also a definitive biosignature. On our planet, phosphine is only produced in 2 ways: in industrial laboratories by human beings, or by anaerobic microbes thriving in oxygen-free environments like swamps, sludge, and the intestinal tracts of animals. It requires an enormous amount of energy to force phosphorus and hydrogen together. In the highly oxidized atmosphere of Venus, any phosphine should be rapidly destroyed. It shouldn't be there. Yet, the data suggested it was present in concentrations of 20 parts per billion. The immediate implication was staggering. Could there be an aerial biosphere? Could microscopic Venusian life have retreated to the clouds billions of years ago when the surface boiled away, evolving to survive in droplets of sulfuric acid? The discovery ignited one of the fiercest scientific debates of the modern era. Almost immediately, rival teams rushed to reanalyze the data. Some claimed the signal was a phantom, a simple calibration error in the telescopes. Others argued that it wasn't phosphine at all, but rather a misidentification of sulfur dioxide, which is abundant on Venus. Still, others proposed unknown exotic photochemical or geological processes that could create phosphine without the need for biology, perhaps explosive volcanic eruptions injecting phosphorus into the upper atmosphere. Yet, years later, the debate continues. Subsequent independent analyses have recovered the phosphine signal in legacy data from NASA's Pioneer Venus probe from 1978, which actually sampled the atmosphere directly but had its data overlooked. Whether the phosphine on Venus represents an unknown chemical pathway or the first detection of alien life, it fundamentally broke our assumptions. It forced us to realize that the universe doesn't care about our narrow definitions of habitability, and that the greatest mysteries might be hiding right next door, suspended in a highly acidic, toxic haze. Number 7. The planetary defense test. Look up at the night sky, and it appears peaceful, static, and serene. In reality, we are living inside a cosmic shooting gallery. Our solar system is littered with the debris of planetary formation, millions of rocks traveling at hypervelocity. 66 million years ago, a rock the size of Mount Everest slammed into the Yucatan Peninsula, unleashing the energy of 1 billion nuclear bombs and wiping out the dinosaurs. They went extinct because they didn't have a space program. Up until the last decade, humanity shared their exact vulnerability. If we spotted a civilization-ending asteroid on a collision course with Earth, we had absolutely no proven capability to stop it. It was a mathematical death sentence. That changed on September 26th, 2022. NASA launched a vending machine-sized spacecraft called DART, the Double Asteroid Redirection Test. Its target was a binary asteroid system located 7 million miles from Earth. The system consisted of a larger asteroid named Didymos and a smaller, 525-foot moonlet orbiting it named Dimorphos. Neither posed a threat to Earth. They were selected strictly as a cosmic target practice. The mission objective was beautifully, brutally simple. Hit the moonlet with a spacecraft traveling at 14,000 miles per hour and see if the kinetic impact could measurably alter its orbit. The sheer audacity of the engineering required is difficult to comprehend. DART had to autonomously navigate across millions of miles of empty space, identify a tiny, dark rock that was barely a pixel in its camera until the final minutes, and adjust its trajectory in real time, at speeds where a fraction of a second of lag would mean missing the target entirely. As the live feed beamed back to Earth, we watched the surface of Dimorphos grow larger and larger. We saw a desolate, boulder-strewn wasteland, not a solid rock, but a fragile rubble pile held together by weak gravity. In the final seconds, the images became astonishingly clear, showing individual stones and craters. Then, the screen went red. Signal lost. Impact. The collision excavated over 2 million pounds of rock and dust, blasting a brilliant tail of debris tens of thousands of miles into space, temporarily turning the asteroid into a man-made comet. But the real triumph came in the weeks that followed, as Earth-based telescopes measured the orbital period of Dimorphos around Didymos. Prior to the impact, it took 11 hours and 55 minutes for the moonlet to complete one orbit. NASA's benchmark for success was altering that orbit by 73 seconds. When the calculations were finalized, the results defied all expectations. DART had shortened the orbit by a massive 32 minutes. This event marks a profound shift in the history of our species. For the first time in the 4.5 billion-year history of Earth, a biological organism actively and measurably altered the celestial mechanics of the solar system. We moved a celestial body. The planetary defense test proved that if the day ever comes when the cosmos takes aim at Earth, we are no longer helpless victims of orbital mechanics. We have the technology to reach out into the void and punch back. Number 6. The sample return. In the search to understand where we come from, we have to look backward. Earth is a geologically active planet. Its tectonic plates, oceans, and weather systems have completely erased the geological record of its own birth. To understand the dawn of the solar system, we must look to the asteroids, the leftover building blocks, the untouched scrap material from the construction of the planets. In September 2023, the OSIRIS-REx mission culminated in an event that delivered the most pristine, dangerous, and scientifically invaluable dirt ever brought to Earth. The target was Bennu, a near-Earth asteroid shaped like a spinning top, roughly the height of the Empire State Building. Bennu is a carbonaceous asteroid, meaning it is rich in carbon, the backbone of all known life. But Bennu is also classified as a potentially hazardous asteroid, with a non-zero chance of impacting Earth late in the 22nd century. The OSIRIS-REx spacecraft arrived at Bennu in 2018, and immediately, the asteroid fought back. Scientists had expected a relatively smooth surface, somewhat like a sandy beach, based on thermal imaging. Instead, when the spacecraft's cameras snapped the first close-ups, they revealed a nightmare of jagged boulders, towering rocks, and treacherous terrain. There were no safe, wide-open landing zones. The engineering team had to meticulously map the entire asteroid down to the centimeter to find a site just a few meters wide, surrounded by house-sized boulders. Then came the collection event in October 2020. The spacecraft slowly descended toward the surface to perform a touch-and-go maneuver. The plan was to kiss the surface with a robotic arm, fire a blast of nitrogen gas to kick up dirt, capture it in a collection head, and immediately back away. But when the collection head made contact, something alarming happened. The surface of Bennu offered almost no resistance. It wasn't solid. It was a loosely bound collection of gravel held together by microgravity. The spacecraft didn't just touch the surface, it plunged into it. The arm sank nearly 20 inches deep into the asteroid, like it was diving into a pit of plastic balls. If the spacecraft hadn't immediately fired its thrusters to retreat, the entire multi-billion-dollar probe would have been swallowed whole and buried alive inside the asteroid. It escaped, bringing with it a substantial sample of extraterrestrial material. On September 24, 2023, OSIRIS-REx flew past Earth and dropped its sample return capsule. It streaked through the atmosphere and landed softly in the Utah desert. When scientists finally opened the canister in clean rooms, what they found exceeded their wildest dreams. They didn't just find carbon and water-bearing clay minerals. They found the chemical precursors to biology. They found uracil, one of the fundamental building blocks of RNA. They found complex organic molecules that predate the existence of our planet. This single sample provides hard physical evidence for the theory of panspermia, the idea that the early Earth was a sterile rock, and the ingredients required to spark life were delivered from the deep dark of space by impacts from asteroids exactly like Bennu. We hold in our hands the literal seeds of our own existence. Number 5. The Martian flight. Sometimes, the greatest breakthroughs aren't about discovering a new object, but achieving something that the laws of physics heavily dictate shouldn't be possible. When NASA's Perseverance rover landed in Jezero crater on Mars in February 2021, strapped to its underbelly was a small 4-pound piece of hardware that looked like a fragile drone. This was ingenuity. The challenge of flying on Mars is difficult to overstate. The gravity is only 1/3 of Earth's, which helps, but the atmosphere is the real killer. The Martian atmosphere is roughly 1% the density of Earth's at sea level. If you stood on the surface of Mars and waved your hand, you would barely feel the air. Aerodynamically, trying to fly a helicopter on Mars is the equivalent of trying to fly a helicopter on Earth at an altitude of 100,000 feet, more than twice as high as commercial airliners fly, in a region where the air is so thin it borders on a vacuum. To generate enough lift in this near vacuum, ingenuity required engineering pushed to the absolute breaking point. Its specialized carbon fiber blades had to span 4 feet across and spin at a blistering 2,500 revolutions per minute, about 5 times faster than a standard passenger helicopter. Furthermore, it had to survive the brutal Martian nights, where temperatures plummet to minus 130 degrees Fahrenheit, threatening to crack its delicate electronics and freeze its batteries. And because radio signals take up to 20 minutes to travel between Earth and Mars, there could be no joystick. Ingenuity had to fly itself autonomously, using onboard cameras and algorithms to track the ground and correct its own flight path in real time. On April 19, 2021, Ingenuity spun up its blades. It lifted off the rust-red dirt, climbed to an altitude of 10 feet, hovered in the alien air for 39 seconds, and safely touched back down. It was an undeniable Wright brothers moment. In fact, a tiny swatch of fabric from the original 1903 Wright Flyer was taped to a cable beneath Ingenuity's solar panel, bridging the first flight on Earth with the first powered, controlled flight on another world. Ingenuity was originally designed strictly as a technology demonstrator. The mission plan called for up to 5 flights over 30 days. If it achieved that, it would be a resounding success. Instead, this fragile machine refused to die. It survived winter dust storms, software glitches, and dead sensors. It transitioned from a demo to an active aerial scout for the Perseverance rover, mapping out treacherous terrain and seeking out ancient river deltas. By the time its mission finally ended in early 2024, due to rotor blade damage during a rough landing, Ingenuity had logged 72 flights. It proved that the skies of other planets are open to us. We are no longer restricted to crawling slowly across the dirt. We can take to the alien air. Number 4. The Water World Signal. For a long time, the search for exoplanets was a numbers game. We found hot Jupiters roasting near their stars. We found frozen, dead rocks. But the holy grail of astronomy has always been finding an Earth-like planet in the habitable zone, the orbital region where temperatures allow liquid water to pool on the surface. Without water, life as we know it cannot exist. In 2019, astronomers using the Hubble Space Telescope made a monumental breakthrough. They were observing an exoplanet designated K218b, located 124 light-years away in the constellation Leo. K218b is what we call a sub-Neptune, or a super-Earth. It's roughly 2.6 times the radius of Earth and about 8.6 times as massive. It orbits a red dwarf star, and critically, it sits squarely inside the habitable zone. As the planet passed in front of its host star, the starlight filtered through the planet's atmosphere. By analyzing the spectrum of that light, scientists detected the unmistakable signature of water vapor. This was the very first time in history that water was detected in the atmosphere of a planet orbiting in a star's habitable zone. But the reality of K218b is far more unsettling and strange than a simple Earth 2.0. Because of its immense mass, the gravity on this world would be crushing. It is highly unlikely to have continents or a rocky surface like ours. Instead, scientists hypothesize that K218b is a Hycean world, a planet completely covered by a global ocean thousands of miles deep, smothered beneath a massive, thick atmosphere composed primarily of hydrogen. Imagine it. A world with no land masses, no shores. Just an endless, dark, global ocean boiling under a crushing atmospheric pressure that would instantly implode any submarine we could build. The light from its red dwarf star would filter through the thick hydrogen sky, casting a dim, crimson glow over the endless waves. What makes this discovery truly profound is what it means for the prevalence of life. Hydrogen-rich atmospheres act as a powerful thermal blanket, meaning Hycean worlds could remain habitable much further away from their stars than Earth-like planets. And these types of planets are statistically the most common type of world we find in the galaxy. More recently, the James Webb Space Telescope turned its mirrors toward K218b and detected carbon-bearing molecules like methane and carbon dioxide. But more unsettlingly, it picked up a tentative, weak signal of a molecule called dimethyl sulfide. On Earth, dimethyl sulfide is only produced by life. Specifically, it is emitted by phytoplankton in marine environments. The data is still being verified, but the implication is staggering. K218b forces us to expand our imagination. The first alien life we find might not be crawling on a green, rocky world. It might be blind, bizarre biology, swimming in the lightless, crushing depths of an infinite alien ocean. Number 3. The second visitor. Space is mostly empty. The distances between stars are so unfathomably massive that for all of human history, we believed our solar system was a sealed, isolated bubble. The sun's gravity holds our planets, comets, and asteroids in a tight gravitational dance, and nothing gets in or out. That illusion was shattered in 2017 with the discovery of Oumuamua, a bizarre, cigar-shaped object that became the first recognized interstellar interloper. But Oumuamua was a frustrating ghost. By the time we spotted it, it was already racing out of the solar system. It showed no comet-like tail, emitted no gas, and left scientists arguing fiercely over whether it was a weird rock, a nitrogen iceberg, or, as some prominent Harvard astronomers suggested, a piece of alien technology. We simply didn't have enough data. Then, in August 2019, an amateur astronomer in Crimea named Gennady Borisov spotted a smudge of light moving against the background stars. This was 2I Borisov. Unlike Oumuamua, 2I Borisov left no room for doubt. It wasn't a strange, silent rock. It was a highly active, brilliant comet. As it plummeted toward the sun at a staggering speed of 100,000 miles per hour, the heat caused it to sublimate, actively venting a sprawling tail of gas and dust thousands of miles long. Its trajectory was hyperbolic. It was moving far too fast to be bound by the sun's gravity. It had fallen from the deep interstellar void, passing through our system like a bullet, destined to return to the dark. The breakthrough here wasn't just its origin, it was what it allowed us to do. Because Borisov was actively venting gas, astronomers could use spectroscopy to sniff its chemical composition. For the first time in human history, we were able to directly analyze the pristine, frozen material forged in an entirely different star system. When we looked at its chemical makeup, we found high concentrations of carbon monoxide, much higher than anything typically found in the comets native to our own Oort cloud. This suggested that 2I Borisov was born in a star system profoundly different from our own, likely forming in a bitterly cold outer region of a red dwarf system, before being violently ejected into the galaxy by the gravitational kick of a passing giant planet. The terrifying reality exposed by 2I Borisov is one of scale and frequency. If we found two interstellar objects within just 2 years using our current, relatively limited scanning technology, the math dictates that the interstellar medium is absolutely saturated with these rogue bodies. There are likely thousands of alien rocks passing through our solar system at this exact second. They are ghosts from dead stars, frozen remnants of alien worlds that were destroyed or ejected billions of years ago. Our solar system is not a sealed bubble. We are driving through a cosmic blizzard of interstellar shrapnel, constantly brushed by the silent debris of a violently active galaxy. Number 2. The Sun's portrait. Our Sun is a monster. It contains 99.8% of all the mass in the entire solar system. It is a continuous, unyielding thermonuclear explosion held together by its own massive gravity. And for centuries, it has harbored a mathematical impossibility that completely baffled physicists. The surface of the Sun, the photosphere, burns at roughly 10,000 degrees Fahrenheit. But as you move outward into the Sun's atmosphere, known as the corona, the temperature doesn't drop, it dramatically spikes. The corona burns at a blistering 2 to 3 million degrees Fahrenheit. This violates basic thermodynamics. It's the equivalent of walking away from a campfire and finding that the air a mile away is thousands of times hotter than the fire itself. What was heating the corona? To answer this, NASA realized they had to do something bordering on insanity. They had to touch the Sun. In 2018, they launched the Parker Solar Probe. Its mission was to fly closer to our star than any human-made object had ever dared. The engineering required to survive this environment defies belief. The probe is protected by a 4.5-inch thick carbon composite heat shield. While the front of the shield reaches temperatures of 2,500 degrees Fahrenheit, glowing a blinding cherry red, the delicate scientific instruments hiding just inches behind it in the shadow remain at a comfortable room temperature. In December 2021, the announcement was made. The Parker Solar Probe had officially crossed the Alphen critical surface. It had entered the corona. It had touched the Sun. The conditions the probe experienced are terrifying. Because of the immense gravitational pull of the Sun, the probe achieved speeds exceeding 430,000 miles per hour, making it the fastest object ever built by humanity. At that speed, you could fly from New York to Tokyo in under a minute. As it plunged into the multi-million degree plasma, Parker didn't just survive, it recorded. It beamed back footage that looks like it was ripped from a science fiction horror film. The cameras captured the visceral, violent reality of the solar wind. We saw magnetic switchbacks, bizarre, sudden reversals in the Sun's magnetic field that whip through the plasma like snapping tethers. We saw the probe literally fly through coronal mass ejections, billions of tons of radioactive plasma blasted from the Sun's surface, washing over the camera lenses in a storm of highly charged particles. By diving into the inferno, Parker solved a major piece of the coronal heating mystery, tracing the source of the high-speed solar wind directly back to magnetic funnels protruding from the Sun's surface. But beyond the hard data, the breakthrough is a philosophical one. We sent a fragile, robotic emissary into the most violent, destructive environment in our solar system, an environment of incomprehensible heat and radiation. We looked at the engine of our existence directly in the eye, and we survived. Number 1. The deepest eye. Every time we build a bigger telescope, the universe gets darker, stranger, and exponentially larger. The Hubble Space Telescope changed our understanding of reality in the 1990s when it stared at an empty patch of black sky and revealed thousands of galaxies. But Hubble was inherently limited. Because the universe is constantly expanding, the light from the most distant, ancient galaxies is stretched out as it travels through space. By the time that light reaches Earth after 13 billion years, it is stretched beyond the visible spectrum and into the infrared. Hubble couldn't see it. Those ancient galaxies were invisible to us. Enter the James Webb Space Telescope. The JWST is the most complex machine ever built for space exploration. Its 21-foot primary mirror, composed of 18 gold-plated beryllium segments, was designed strictly to capture the faint heat signatures of the early universe. But the engineering tension surrounding its launch in late 2021 was unparalleled. It was too large to fit in any rocket, so it had to be folded up like cosmic origami. Once it was launched to a point 1 million miles away from Earth, too far for astronauts to ever fix if something broke, it had to autonomously execute a deployment sequence involving 344 single-point failures. If a single pin failed to drop, if a single hinge jammed, the $10 billion project would become space junk. It performed flawlessly. And on July 11, 2022, NASA released the first operational image. Webb's first deep field, SMACS 0723. The image is visually stunning, an explosion of thousands of shimmering diamond-like structures against the infinite black. But the true breakthrough requires understanding exactly what you are looking at. The area of sky captured in that image is roughly the size of a grain of sand held at arm's length by someone standing on the ground. In that microscopic sliver of nothingness, JWST revealed thousands of entire galaxies. In the center of the image is a massive cluster of foreground galaxies, whose combined mass is so great that it actually warps the fabric of space-time around it. This creates a gravitational lens, acting as a natural magnifying glass that bends and magnifies the light from galaxies positioned impossibly far behind it. When you look at the distorted reddish streaks pulled into semicircles around the center of that image, you are looking at light that left its source 13.1 billion years ago. You are not looking at stars, you are looking at time travel. You are seeing the universe as it existed less than 1 billion years after the Big Bang. You are witnessing the absolute dawn of reality, the very first structures forged in the aftermath of creation. The James Webb Space Telescope fundamentally shattered our perception of scale. It proved that no matter where we look, no matter how empty a patch of sky appears, the universe is choked with matter, choked with galaxies, choked with trillions of star systems. The deep field image is simultaneously the most humbling and the most empowering photograph ever taken. It reduces human existence to an absolute microscopic irrelevance in the face of cosmic infinity, while simultaneously proving that a species of primates from a rocky water world had the intelligence to build a golden mirror, send it 1 million miles into the dark, and peer all the way back to the beginning of time.